Hi, I'm Dr. Valerie Zonnefeld. I teach in the Dort Mathematics and Statistics Department. I'd like to invite you to join us for a March Madness data analytics battle. Let's learn some more. So, March Madness is a fun thing that happens in the spring with college basketball playoffs for the NCAA. So we're going to use that as our way to learn about data analytics. Data analytics is a field in data science. It uses statistics as well that helps us make sense of data. So ZealLearn defines it as a field that uses scientific inference and mathematical algorithms to extract meaningful knowledge and insights from a large amount of structured and unstructured data. So we're going to use the March Madness basketball tournament to learn about this. And it's a competition for both middle school and high school students. What we're going to do, or you're going to do, is create an algorithm. And algorithm sounds big and scary, but basically it's like a recipe that will choose 10 teams from the NCAA basketball tournament. And then these teams will be assigned a value from 10 to 1, with your top team be given 10 every time they win. So you get 10 points every time they win. Now, before you think, well, I want to make sure I have North Carolina and Duke and all those favorite teams, that's not how this one works. And that's what's different about this, because we're going to create an algorithm that chooses the teams for us. And our algorithm is going to be trained based on what data we think is predictive of winning. So what happens here is every time one of your team wins, you earn points equal to that team's assigned number. So if you're the team that comes out top on your algorithm, your top team, you would get 10 points every time they win. The team that comes out second on your algorithm, you would get 9 points. Your third team, you would get 8 points, all the way down to your 10th team, then you would get 1 point every time they win. Now, one special thing in there is anytime you have a Cinderella team that wins, you get there's an extra bonus for that. So keep track of that as well. And a Cinderella, for those of you that aren't aware, is a team that makes the tournament, but they're not necessarily expected to win. So there are 16 seeds in the tournament. The top 8 are seeded to win. They're expected to win. 9 through 16 aren't necessarily expected to win, and so they're considered Cinderella seeds. And so if they were to win, then you get extra points for that each time they win as well. So what you're going to be doing and spending time doing is algorithm testing. So you'll get data from previous year's tournaments, and that data is what you're going to analyze to make decisions about how your algorithm will choose teams that you think will win. So you'll get this spreadsheet with all the stats on it, and in teams, and possibly on your own, you'll create algorithms and test how they perform. And you could test how they perform on previous years. Now, so that's part of what you're doing when you explore, and you'll submit the algorithm that performs the best. So the one that gets you the most points is what you're going to submit. And there are infinitely many possible algorithms on how to choose these teams. So some of the example algorithms that you could do would be to choose the top 10 teams based on the average point differential per game. So basically, how far did they win or lose by? And most of these teams are going to be positive. They're going to win because they actually made the tournament. So you could organize based on that. Or you could rate the teams using a weighted average, and we'll look at an example of that as well. Or you could do like something sophisticated, like a regression model. It can be as hard or as easy as you want, but you want something that's going to be accurate. So let's start by looking at that point differential, and we'll look at the year 2016 to see if it's a good approach to it. So the point differential algorithm for 2016, if we went into the spreadsheet and sorted based on that, the top team would be this Stephen F. Austin. And so every time they win, you would get 10 points. Now notice the points that they actually weren't. They only won once, and the points that you actually earned for them were 15. That's because they're Cinderella. The little star in there says Cinderella. So we got 15 points for them. That was kind of a missed opportunity, because at 10 points a thing, you could have gotten, at 10 points a game, you could have gotten 50. And so if we look at this algorithm here, it earned 107 points. Now, the maximum points that you could earn would be 695 if, everything landed right. 1, nobody's ever picked perfectly. And 2, that also implies that the only teams that win are Cinderellas, which is highly unlikely. So 695 is really unachievable. When I've looked at teams that do well, they tend to be, close to 200, over 200 a little ways. So if you can get an algorithm that's getting close to 200, you're doing really well. And you never know what's going to happen in that year. And that's what data analytics does. Data science looks into processes that we don't know everything about and tries to make good predictions based on them. So if we look at this one, it's not a great algorithm. It's only 107, but I'm not quite ready to give up on it yet, because one thing I notice when I look at this algorithm is there are 4 regions in the basketball tournament, and only 3 of the regions are represented here. So we're missing points from the West region. We're missing points from the West region. So what we could do is use the same algorithm, but make sure that we get teams out of every region. So what we would do is take the top 2 teams from the East, the top 2 teams from the Midwest, the top 2 teams from the South, and then also make sure we get the top 2 teams from the West, because we're not getting any points out of that region. And when you submit your algorithm, that's the type of explanation you'll put in there. Like, we're choosing the top teams out of each region based on point differential per game. And so we would do something like that. Now, if we chose the top 2 out of 4 regions, that's only 8 teams. So then you would also need to say, and then we choose the top 2 remaining teams after that. And so if you look at what I have here, this would be a regional that uses the average point differential algorithm, and we get our West in there. And so we do get a few more points because the West is in there, but we're limited. We only really went up 111. So it didn't help a ton. It's maybe not the best approach. And if I think about it with my basketball hat on, part of that could be that I don't know who Stephen F. Austin is. They're not like a big name basketball team. And if you look at what conference they're in or who they're playing, they're probably not playing tough competition. So they're beating teams by a long ways, but they're beating teams that aren't very good. So some of that stuff I just said there, you might think, well, I don't know basketball. I'm never going to know how to do this. It doesn't mean that you don't need to know basketball to do well in this, because sometimes knowing basketball means you start to make decisions with your heart instead of with your head. And if you need to know a little basketball, then look at this sheet that you got that says basketball statistics description. So it just kind of, each statistic that you have is outlined in here and gives you information, what's a rebound, and what ones do you want to have a higher score on. Some of them you want a lower score. So if it's turnovers, you don't want that to be high because that means you're losing the ball. So this algorithm that we're doing here, not great. So what we can do is explore the data a little bit more. So let's start by doing that. So if we head to the spreadsheet here, so your teacher gave you a link to the spreadsheet, but it's locked for you. And the reason it's locked is because otherwise all of you would change it for each other and it would start to be a mess. So the first thing that you need to do is to duplicate the sheet. So you're going to go over here to File, and you're going to say make a copy and name it something meaningful to you and save it wherever you save your things. And here we have a copy of it. And I want to make this just a little bit bigger for you guys. And so when you're exploring the data, if you look, I'm looking at 2019 here, all the teams are on the left. And maybe I want to look at these teams alphabetically. So all the great stuff in a Google Sheet happens under this green triangle. So you click on the green triangle and you say sort A to Z. So now I can see things alphabetically. But it turns out the alphabet doesn't really help me much in statistics. So I'm probably not going to keep it that way. But these green triangles help you sort everything. And so when you're starting to look, you want to just do some exploring in there to see, well, what is important? What helps a team do well? Like, you could do it based on losses. If I look over here at column G, if I sort based on losses, and let's go A to Z, so these are the least amount of losses, well then Buffalo would come out on top. Notice that one of these columns is in yellow, and the reason that's in yellow is that's what you're trying to predict. So this tells us who won the most in the 2019 tournament. And we're trying to predict that for this current year. We don't know it yet because it hasn't happened. So we're going to use this data to see, well, what is it that made these teams that won a lot? So I'm going to just start by sorting by number of tournament wins, and I'm going to go biggest to smallest. So biggest would be Z to A. And so Virginia won the tournament. They won 6 games. And so if you had chosen Virginia in that year, you would have got 60 points, which is a big deal. And so if I have it sorted such that, most wins are on top, then it's also interesting to scroll through the data, and there's a lot of it. And, if you look at scoring differential that we were just using, there's a lot of variance in there. There's a lot of different scores in there, so I don't know that it's a super predictive statistics to include. Total scoring differential is similar in that it just takes the total points for the whole season. This would be how many points the other team was allowed to score, so this would be a measure of stronger defense. You could also look at losses or wins. This gives an idea of strength of schedule. We have ESPN strength of schedule, and that's something that I'm guessing that the Stephen F. Austin didn't do well on that year, because I don't think they played tough teams. So basically you can just go through here and look at which teams ended up being, which statistics ended up being predictive of winning more winning more there. So that's the spreadsheet to start with. And that's some of the stuff you can do with it. But I want to show you a few more things so that you can keep playing with this data and not just sort things, but actually make some algorithms, make some formulas. So if I want to show you this next way that we can look at it, the weighted average algorithm. So a weighted average is when you say, let's just say I think 3-point percentage is important, I think free throw percentage is important, and I want the assist to turnover ratio. So if I choose those 3 and I want that to be a part, I could just add the 3 up. But let's say I have even stronger, when I was looking through the data, I think that 3-point percentage is predictive, but I think free throw percentage is even more predictive. And since I think it's even more predictive, I'm going to take that variable and multiply it by 2. And similarly, I think assist to turnover ratio is even more important. In fact, I want it to be 3 times. I want it to weigh 3 times as much as that 3-point percentage. So you would just add these 3 variables in there and then divide by 6. It finds an average for them. So let's play with that a little bit in the spreadsheet. So 3-point percentage, free throw percentage, and assist to turnover. So if I go into my data here, I'm going to need to make a new column for this new algorithm, this new recipe that I'm testing out. So what I do is I click on the top here and see that I get this nice little triangle here. On the top, I'm going to say insert one left. And so I'm going to call this, your future self wants you to name this something helpful. So I'm going to call it weighted average 3 free throw and assist to turnover. Okay, so I put that in there. And now what I need to do is make that algorithm that I just said. And when you want a spreadsheet to do something for you, you always start it by saying, hey, do something for me. And you start that with an equal sign. So you put an equals in there. And the first thing I said that I wanted was my 3-point percentage. So I'm going to click on this cell here, N2. Now don't actually type in 0.409 because spreadsheets are very powerful and we want to harness that knowledge so that it works for us. And if we type in just the cell block, then if that cell changes, it automatically updates in our formula over here. And then we can also copy it down for others. Spreadsheets can make you feel really powerful because they do a lot of things for you. It's one of those situations where you work smarter, not harder. I'm thinking now, as I just entered that, if we go back to the PowerPoint, remember I need a parentheses around here. So let's go back to my spreadsheet and we'll start that parentheses here. And so we wanted 1 times that, and the other thing that we wanted was 2 times free throw percentage on the season. So let's head back. So we're going to say plus 2. And the way that you tell a spreadsheet to do times is with the asterisk symbol. It's above your 8. So 2 times, and then free throw percentage. So let's go find free throw percentage. Oh, there it is. So that's in cell Q2 for me. And then the last thing that we had wanted was assist to turnover ratio, and we wanted to multiply that by 3. So I'm going to type a 3 in, and I multiply, which again is my asterisk, and then we'll find assist to turnover ratio. Okay, and scrolling back to my formula, if I edit up in here, then I'm going to end that with my parentheses. And remember, we had said that we wanted to divide by 6. So I do my slash for division, divide by 6, enter. Okay, and so I entered it in, and I know for Virginia, on that algorithm that we just made up, they got 1.119. I think that's kind of gross looking for a few reasons. So the first thing I don't like is the fact that it's so big, it's hard for me to really see what the number is. So if I click on this top here and I highlight the whole column, I can get it so that it's not showing so many numbers, so I can focus on actual significant digits. So what I'm going to do is click here until it's just got 2 afterwards, and that's up to you how many you want to show, but this makes it easier for me to see what's going on. So I did that for the whole column since I had it all highlighted. The other reason I think that's kind of gross is because we were basically finding a weighted average of free throw percentage, 3-point percentage, and then assist to turnover ratio. One of those things doesn't get along because your free throw percentage is a percentage, right? And your 3-point percentage is also a percentage. Now the assist to turnover ratio is a number. If we look at this column here, it's a number that varies from, it looks like 0.9 to 1.6. And so that's getting a lot of emphasis in this. It's getting like too much importance, basically. So one thing you can do is kind of scale back one of your variables so that they're all the same. And I'm going to click to a certain slide here a second to show you if you think, I can do this, I want to tackle this, what you can do is scale, and this is the information for how to scale. You do your min minus your max minus your min, and then you take the value that you have minus your min. That's the real way to do it. If you think, wow, that seems complicated, then you can take a guess, because that's fine as well. I mean, there are a lot of personal choices when you're doing data analysis. So let's go back here. I said that I didn't really I thought it was gross because the assist to turnover is getting too much weight, basically. It's getting too much importance. And so I could scale it back a little bit. Let me go back to assist to turnover. I think it's important because I wanted to multiply it by 3, but just based on the types of numbers that are going in there, it's getting too much weight, because 3-point percentage is likely like a 0.3 or a 0.4, and these are all coming in at 1.4, 1.5. So I think it's just a little too important. So what I could do is divide by 3 or divide by 2 so that it wasn't so that based on the numbers coming in, it wasn't given so much weight. And I'm going to adjust my formula to do that. So if I go back here, if I look at my formula up in the formula box, I had multiplied by 3 because I thought it was important, but the numbers coming in were giving it greater weight. So I'm just going to get rid of that multiply by 3. And you want to do your edits up in the formula box because you have less weird things happening then. Sometimes, yeah. So I just got rid of the 3 times, or the 3 in the asterisk, and I go enter. And that looks more like a percentage, and I feel more comfortable with it. Now is another time to feel real powerful. This just calculated for Virginia, but I need to know for every team in the tournament. And that would be a lot of work to enter for all of them. But what I can do is see when I've highlighted this cell that I like, it's got this nice blue triangle in the bottom. I can just pull that down to my bottom team here and let go, and it's been calculated for each team. That's super handy. But the thing I really want to know is, well, for 2019, who did well on this? What would it have selected? So that means I want to filter it. So I'm going to click under my green triangle here, and I want to filter big to small because these are good things to have happen. And this isn't bad here because if you look at wins, Gonzaga would have got 30 points because they would have been the best. Belmont, that's a little bit of a miss, no points on them. Tennessee and Virginia. And by the way, you go, well, they're both 0.59. It's calculating for the decimals to the right of it. And remember how if I wanted to see another decimal, I could click on the top up here and then click this, and that would increase my decimal point. And so you can see, well, yeah, Belmont, this rounded to 0.59. So these are the teams I would get. Virginia won the tournament and they still end up in there. So that's not bad. But it would be interesting to know how many points we got for that, wouldn't it? So let's calculate how many points we would have gotten. I'm going to add another column to the left here. And the way that we did that is I highlighted my G, and then I got this nice little triangle. I click on it. I say insert one to the left, and we're going to say points. Okay, points. I'll just call it points, okay? And in points, I want to calculate how many points they get for every time they win. And they would get, Gonzaga would get 10 points, right? So I need to have that, included in my formula at some point. So I'm going to add myself another column here. I click on the green G, and this nice triangle shows up, and I say insert one left. And in here, I'm going to say ranking. Okay, so I've got my nice ranking, and Gonzaga's my best. They ended up on top, so I'm going to give them 10 points. And then Belmont was second, so they're going to get 9 points. And I enter that in, but it's, I'm going to quick fix that because that's a little gross. And I want you to see how powerful a spreadsheet can be. I have a pattern started here because I have two numbers. So I make them, I drag across them so they are both highlighted. And now notice I have this square, this blue square. I can pull it down. I don't know how far I need to go. And that pattern continues. And so this is the number of points they'll get each time they win. So what I want to do now is to go over here to points and calculate how many points I get for Gonzaga. So the way that you calculate points is you want to do number of tournament wins times ranking. Well, how do you tell a spreadsheet that it's time to do something? With an equal sign. So I put in my equal sign, and then I click on cell G2, and I want to multiply that, which is my asterisk, times cell F2, and I push enter. And that tells me that they got 30 points. That's not a bad start. And I want to calculate that for my top 10. So I grab that blue square again, and that's how many points I would have gotten. Now, those of you that are really paying attention will notice that's not all the points they got because there were a couple Cinderellas in there. We've got Belmont as a Cinderella, we got Murray State as a Cinderella, and we've got Liberty as a Cinderella. So there were extra points gained there. So what I want to do to include that Cinderella aspect is I need to make my formula better. And notice that if it is a Cinderella, it gets a 1. So what I'm going to do for points is I'm going to add on to my formula and say plus, and I'm going to say plus Cinderella. So if they were a Cinderella, there's a 1 in there and it's going to multiply. And if they were not a Cinderella, it's a 0 and nothing will come out of it. So it won't harm anything. So I'm going to go Cinderella times number of wins, but Cinderella times number of wins. I don't know that came in right. Just a second. Looking in my formula sheet. So Cinderella, click, and then I need to do my asterisk times number of wins. And how many points do you get each time they win? It's 5 points, so I'm going to do asterisk times 5. Enter. And notice that didn't change anything for Gonzaga because they weren't a Cinderella. Now I'm going to pull that down over my remaining teams, and that did add some points. And I could grab a calculator right now and add all those points up in that column. But with a spreadsheet, we work smarter, not harder. So I'm going to scroll down to the bottom here. and say, hey, add this thing. And the way that you say, hey, add this thing is you click right beneath your bottom team. So I'm in row 70 here. And if I look up here, it says functions. I'm going to click on that and say sum. And I want to sum from the 69 up to 62 here. So it says sum, and you can see up here in the function bar, H2 to H69. Those are the cells that we're including. Enter, and I got 146 points, which is not bad. Not bad for a first attempt at something. Okay, let's look back at where we were at. So for the weighted average for 2016, when it was calculated, it did 107 points. So it was quite a bit better in 2019, actually. But the other thing that happened here was it was regional. So since it was regional, they made sure that they picked out of every region and to balance that. So we could go back into ours if we wanted and calculate that as well. And that we would have to do by hand, though. That would be more of a filtering, by hand, and you would include that in your algorithm that you submit that describes it. So if we wanted to make sure we included each region, I'd have to go over here, and there's 2 west in here, which is good. I've got 2 east, which is good. I've got 2 south, and what I'm missing is Midwest. So I would need to kick out this bottom east here. Liberty would need to go, and I would need to grab the next highest Midwest, which would be Utah State. And in this year, it doesn't really add a lot since they didn't win it all. But then you would actually have to include that one. So we would pull by hand. You would pull out our 10th team, which is the East here, and we'll give them a 0. And that means they get no points here, and then we'll actually put in our Utah to make sure we have 2 out of the Midwest. And Utah then would be our 10th team, which means that they gain 1 each time. Oh, I gotta pull that formula down. Okay, and it did nothing to it. But if we look on the bottom, we lost 2 points over that. So that's how you would adjust it for that. And scaling I already mentioned. So that's kind of what's going on. You have a quick start guide that you can use. Just kind of goes over the things that I've talked about there in case I went too fast. And here is also the statistics as well as some sample algorithms on the back. So you can start developing and testing algorithms now, anytime. Your algorithm needs to be submitted by your sponsor or your teacher before Selection Sunday, so likely that Friday before Selection Sunday, because once they choose the teams, you don't want to, you need your algorithm to choose, not you choosing the team. So that's when that needs to be due. Stay tuned for information. Drake University also helps in this effort, and they host a data science conference. So stay tuned for information on that. And I forgot, we got to talk about prizes here. There's a really cool trophy. It's large, 2 trophies actually, a traveling trophy that goes to the teams that do the best. So to qualify, your school must sponsor at least 3 teams. And then what happens is the school that has the highest average for their top 3 teams is selected the winner, and there are actually 2 schools that are selected, one for the smaller school, so that's 500 or less students, and or 500 and more for larger, and then less than that for the smaller school. And then in addition, there's also some swag. So the top team in each school will receive a Dort water bottle. So not only for the top school, but also the top team in your school. So there's some cool stuff going on here. And it's just kind of fun to watch how your teams do because you have a vested interest in them. I want to say thank you to Rick Spellerberg from the Iowa Center for Interdisciplinary Training, as he does a lot of the work with this and a lot of the background information, and he'll be sending out updates after rounds telling you how you're doing. And then I also want to just share a little bit about the NOISE program at Dort University, because that's part of what funds my work here. So the NOISE Scholars Program is great for anybody interested in education. It's $15,000 scholarships in the junior and the senior year. So if you're interested in teaching science or technology or engineering or math, talk to me. I've got scholarships that we can talk about. And then another unique program is the RU STEM program, and that's for students interested in studying math, engineering, and computer science, and that's $10,000 a year, but for 4 years. So there are opportunities. There is a huge need right now for individuals with those quantitative abilities and interest in STEM, and because of that need, outside sources like the National Science Foundation are giving money to help students like you learn about that. So I hope you enjoy the competition. I can't wait to see what algorithms you come up with, and best wishes.